Okay, here we are. Starting at the beginning, I got my coffee. Went back to the Golden Girls Cup here today. The last video I'm doing is actually, interestingly enough, 1 through 16? I guess that's what we're going to do here, 1 through 16. And yep, all right. So, Geometry Unit 1, Similarity and Scale Factor. Let us rock and roll. Okay, number 1. Oh, where's my blank paper? Oh, Mr. Miller. Be more ready than this. All right. So here's the deal. When we know, I'm telling you here that these two lines are parallel, this one and this one. Thus we have corresponding angles. And since angle M is equal to angle M, we have similar triangles by angle, angle. Okay. So once we've got that, I know I can use proportion or scale factor to solve this. One of my recommendations for students is when you've got two shapes stacked on top of each other like this, to just redraw them separately. So we've got this side is 12 and this is 10 plus x. And then draw the smaller one here, which is 8 and 10. And this is MQ. And then not even doing this top part because I'm not asking for y in this problem. All right, so I have, oh, hey, what's up? Oh, please, just leave it there. All right, well, thank you so much. All right, a student drop off some brownies for a party. All right, so we know that this side is proportional to that side, and we have this side here proportional to this side here. So there's a lot of proportions I could write. I'm just going to go 12 is to 8 in the same ratio that 10 plus x is to 10. So blue to blue, orange to orange. Now I got to cross multiply. Let's go to 8. There we go. Still looking pretty good. So 120. All right, just keep doing some algebra, and there we go. Made it finally. The x equals 5. So got number 1 done. All right, number 2. Number 2 looks a little janky here because my initial grid didn't show up. It was too light in the printer, so I had to just use a pen. That's why these lines aren't particularly sharp. This is a composite shape. So what we have to do is realize that the whole is equal to the sum of its parts. And so we want to break this shape into parts that we can calculate the area of. Like this right triangle here, that's 9 by 3. So, and do I have a calculator? I do, sorta. All right, I do now. Okay, so we got right 1/2 the base times the height, so we're looking at 13.35 or 13.5. All right, so we've got this one here now. Let's get that darkened in. So 1/2 the base times the height is going to be 3. And let's just kind of keep going here and see what else we got. This looks like 1. All right, so we're 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6. So 1/2 5 times 6 is going to be 15. And our last shape, also a right triangle. So we've got to do 1/2. I'll call this the base and this the height. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's 1/2 6 times 6, which is going to be 18. And we just add all these up. So 13.5 plus 3 plus 15 plus 18 is 49.5. All right, units squared. Okay, we're rolling. So this is two ratios that are equal to each other. We are going to just cross multiply. A lot of times you can use scale factor to solve these, but when I got a variable in more than one place, it tends to just be easiest to cross multiply. All right, so let's distribute. Beautiful. Let's collect our x's all on the same side, so I'm going to subtract 2x just because I want it to be positive. And I'm going to minus 21 and say hello. Hey, Kenton, I'm just recording a video. You can come in and set up if you want.
You're just gonna put this, do you have like a cooler or something?
I do have an ice chest in there. It's probably just cold water at this point, but.
Oh, we're
And we get x is equal to negative 5.
I stand wrong.
Yeah, no worries. Alright, so number 4, we've got a dilation. So if the scale factor is 0.5, then you're going to multiply every coordinate by 0.5. So a is going to be, instead of 6, it should be at negative 3. So we're not there. We're definitely not there. And negative 2 should multiply by 0.5 and get to negative 1. So D is already the only one it could be. We might check divide by 2, that works. 4 divided by 2 is 2, negative 8 divided by 2 is negative 4. All right, next problem, number 5. Yeah, all good. I'm stoked on the party. All right, number 5. A scale drawing of the polygon below. Okay. Scale factor of 4, and we're talking about interior angles. Well, interior angles are going to stay the same because it's the same shape, right? So remember, a dilation or a scaling, the size changes, but the shape remains the same. So all these internal angles have to be the same, or else it would change the shape. All right, 6. We've got a scale. We want to do a scale factor. All right, well, it says that they're scaled copies. So if this has to also be 9 because these are both 4. And what are we looking for? The scale factor. And we got the triangle on the right being a scaled copy of the one on the left. So it's going to go this direction. So it's going to be bigger than 1. We're scaling up. So it's going to be 9 divided by 4. Because that's always how you find scale factors. Just like, all right, well, you know, new number divided by your old number is going to give you the scale factor. So, I mean, if you wanted it as a decimal, you could do 9 divided by 4 is 2.25. So this is times 2.25, which is also 9 over 4. It definitely isn't going to scale down, so it's none of those, and it's also not that one. All right, I think we're doing good. I think I could use a cup of coffee. All right, good. All right, here we go. Number 7, triangle DEF is reflected over the y-axis and a scale factor of 3. All right, so remember, if you can reflect over the y-axis, it's going to look something like that. So one of the things to realize is it doesn't move up or down, it only moves left or right. So initially, after the reflection, our y values are going to be the same, and our x values are going to change signs. All right, so that's going to be the triangle after the reflection. Now we're going to scale factor 3. So every point gets multiplied by 3. So from 2, we're going 6, negative 24, negative 33, negative 12, 3, and 0. And that is, I'm like, uh-oh. It's got to be over. They're so similar. My gosh, Mr. Miller, why did you do this to us? But it is this one here. It is A. It took a second to even try to figure out what the difference was. All right, 8. The figure on the right is rotated and scaled. All good in the hood. Which side in the figure corresponds to segment XZ? All right, well, I'm going to kind of brace myself with the smallest side. I'm going to make that kind of blue there. And then we've got the longest side. I'm going to make the longest side orange. Now there's two sides remaining. ZX is the longer of the two. So if I look at these, RZ is the longer of the two. So these would be the corresponding sides. So we're going to go with TR or RT. Now it doesn't matter which letter you start with when you're describing a line segment. why? Hey, stay with me. It's only been 10 minutes. We're going to be done here by 20. Or fewer. Let's see. Maybe we'll pick up speed. Alright, so we got the diagram below. Points A, B, and C are collinear. That means they're on the same line. Okay, point P is not located on the line. Sure. Which best represents A, B, and C through a dilation of a scale factor of 2? So if it's scale factor of 2, the points are going to have to be further apart, because whatever you do for like this distance here, whatever PC is, you would double it, and it would be out here would be the new C. And you would put a line through here, you take this distance, double it, that would be your new B, and you would draw that line, take this distance PA and double it, and that would be your new image point. So that being said, it's not my best diagram, but it is A, because you can see the little primes there. Maybe I need to improve this diagram. Well, if you get out your magnifying glass, clearly you can see that it's this one. This one is scaling down. The points are getting closer to P. Alright, so here we've got a claimed dilation, so we know it's happening. We know they're geometrically similar. And the scale factor, our shape is smaller, so it's going down. Okay, scale factor is going down. I might just look at this distance here. This distance is 3. Maybe I'll just give it a color. This orange distance is 3. This distance is 3, 6, 9. So we're scaling down, right? Because you always start with the one that doesn't have the little primes. That's the pre-image. And so it's going to be a 1/3 scale factor. Because we're multiplying, you multiply 9 by 1/3, you get down to 3. All right, 11. Luckily, I was just helping a student with this problem. And so now I'm going to just immediately highlight the word not. All right, so A and R is true, right? So it's not that one, because that is true. It's worth sometimes just figuring out what the corresponding sides are. Maybe, oh, hey, no, not cool, computer. You don't get to go sleep on me. All right, so now these are corresponding, which you can tell by looking at it, but you can also tell by reading it. BC, right, second and third letter. ST, second and third letter. So AB, first and second. RS, first and second. All right. So let's look at this one here. AB is, in my picture, it's yellow. And RS is yellow. BC is orange. ST is orange. So C is not true, because it's like ratio of yellow to orange and then orange to yellow. That is not. So that's going to be the answer. This one must line up a lot better. So AB is and RS are both yellow. Yellow to yellow, orange to orange. That's fine. And this one is kind of funky looking, but it's just telling you the perimeters, right? Like the ratio of the perimeters is the same as the ratio of the side lengths. That's also true. So let's move on to 12. Okay, so we're told that they're similar. We want to know what has to be true. So what has to be true, we got y is a is equal to y. Well, that automatically doesn't have to be true, because they're not corresponding angles. A has to be the same as x. It doesn't have to be the same as y. Oh, so it's not that. That doesn't have to be true. C and Z, that has to be true right there. They're the last angles. They have to be exactly the same. So C and D must not be the same. And I don't know, let's look A, B. So if we're kind of just thinking about this, and you got BC and YZ. AB, so you got orange to yellow. And we've got, yeah, this is just the wrong, those aren't proportional. I'm sure those aren't either. Not even going to bother to check. I'm sure they're not proportional, or else it would have to be true. All right, so we're going B on that. Yeah, maybe I should just check this last one. Whatever. Let's just check it. Let's give this a color. And we have more party goers.
Hello.
Hello.
Hi, how are you?
I'm good.
Um,
I'm making a video so everyone can
I'm
hear your
sorry.
voice. You had an email. It seemed
Yes.
like it was okay.
Okay, thank you.
All right. Yeah. Okay, so AZ is blue, XZ blue, XY is orange, AB is orange. The ratio of orange to blue, but big, let's just call it big, and then little, and then little to big. So it doesn't really, it's not proportional. The colors lined up, but just imagine this one is bigger than this one. It looks like it might be slightly bigger. You can't do big over little, or one on the left over one on the right, and then one on the right over one on the left. Maybe I should do that, right, left, instead of big, little. So you have right, left, and over here you have left, right. That doesn't work. Okay, you have to be consistent. If you were going to do boom, boom, you'd have to do boom, boom. All right. Well, hopefully that made some sense. All right. You still with me? Good. 13. Okay, so we've got another similarity statement. We want to know what A, B is. So we're definitely going to be writing proportions here. I've got a variable in two different places. It wants to know A, B. Okay, so it wants to know this side. So let's just do 7x is to 4 in the same ratio that 7 is to x. And 7x is to 4, 7 is to x. Okay. I don't like that I'm getting x squared here, so 7x squared. Oh, that's fine. Equals 28. So x squared is equal to 4. So x is equal to 2. All right, no problem. 14. All right. So we've got some parallel lines here. So we've got corresponding angles. We've got angle A equal to angle A. So we've got similar triangles. So if we use the same strategy as before, let's go triangle here. What time is it? 55? Oh, good. I got plenty of time till the next class. All right, AD is 8. Let's just say ADE. DE we're not given. AE is 12. That's probably going to be enough information. Now the bigger one is down here. Oh, let me make sure I'm adequately displaying this work. Oops. There we go. All right, so this is going to be AB. All right, this is the larger one. So we got AE is 12. It says AD is 8, and then it gives AB is 10. That's that whole distance, so it's 10. And it wants to know EC. Okay, so that's 12 plus x, and that's going to be x. All right, there we go. All right, so that's cool. Pretty straightforward proportion writing here. So I'm just going to go 10 is to 8 in the same proportion that 12 plus x is to 12. Again, it's not the only proportion. Lots of proportions you could write. Just whatever one it is should get you the right answer. See what that right answer is. Let's go 96 plus 8x. So what is that, 24? So I'm just a little bit off the page. I don't know, I'm tripping today. Why am I so off the page? Okay, I don't know. Why is that? Alright, so then x is equal to 3. Alright, keep it going here. Almost done. Number 5. This number 5, I know because I worked with a student today, doesn't actually have an answer in this version. Of course, in future years, that will all be fixed. But this year, which is spring 2025, you can just assume that this is a free response problem. All right, so just take point A. Let's get this zoomed up here. And we are at, what are we at? 2, xy, right? And up, I believe it's 10. 6, 8, 10, yeah. All right, so if we're going to dilate, if we're going to translate along this vector, our x values are going to get less by 12. So we're going to be at negative 10. Our y values are going to get less by 2, so we're going to be at 8. That's the new a. And then if we were to then dilate with a scale factor of 1/2, we would be cutting each point by dividing it by 2. So this would be negative 5 and 4. So note to self, let's make that one of the answers, but there you go. 16, last problem. Well, let's just look at this ratio. So 16 to 6, that's the ratio of the height to the width, is this 2.667. So that ratio has to be the same if it's a dilation, because dilation creates geometrically similar objects. So that worked. So A is one of them. See, this one's 1/2. It's twice as tall as it is wide. So that's not 2.66. That's exactly 2. Here, this is actually 6 times, and of course it doesn't look at all similar. That's because it has a much larger height-to-width ratio. Let's do 8 divided by 3, and there we go. A and D. All right. Maybe not the smoothest video I've ever done, but it's the effort and the care that counts. I definitely hope it was helpful. Thank you for listening. Thank you for being wonderful. Remember to stay hip and be kind to each other.